Hello everybody. In this video I'm going to briefly touch upon how to reverse a linked list. So there's two solutions for this normally. You can do the iterative solution, which is the one that I'll just be quickly showing, and then there's also a recursive solution. And I would say that this is a pretty common interview question, so I definitely would try to learn this if you haven't yet. So I'm using LeetCode just to demonstrate this. The question is number 206. And if you look at the left, they give us an example. So given the head of a singly linked list, reverse the list and return the reversed list. So they pass us in a head node, and we need to reverse the linked list given. And for example, if we're given a linked list that is 1, 2, 3, 4, 5, they want a linked list that return should be 5, 4, 3, 2, 1. So pretty much obviously just the reverse order of the top. And I would say the confusing part that people run into for this kind of question is people are typically used to like working with arrays and things where you can just directly index random indices in the list. But with a linked list, you can't. Obviously, you have to start from the beginning node and then work your way through, because we can't just directly be like, oh, let me start at 5 and then from here I can just kind of reverse. But we can't do that because remember, we only move in the left to right direction. If it was a double linked list, that would obviously be a little different. But for example, so obviously 1, 2, 3, 4, 5 would then turn into this. And so I guess I can just implement the code and I can kind of go over the logic behind it. But before you even get into it, you obviously want to handle your base case. This is kind of a part where people might miss in interviews, and it's actually a bad sign if you do miss this part. But our base case in this kind of situation would just to be if the node got passed in did not exist or was null, then there would obviously be nothing to reverse. So pretty much if head equals null, meaning they gave us in no linked list head, then return null. Otherwise, we can just do a few things real quick. Pre would be null, next would also be null. So the goal, I guess, is to actually start at the beginning node, and at every iteration of the list, you want to take, the current node and take the .next pointer that the node has and actually point it backwards. Meaning, if we're at 1, this is going to be the last node in the final list when we reverse it, and in this case, this should actually point to null, meaning it's the last node in the list, and 2 should point to 1. 3 should point to 2, 4 should point to 3, 5 should point to 4. And so based on that kind of behavior, we're going to set a node called current and set it equal to head, because this is where we're going to start. We're going to take prev and set it equal to null, because at the first iteration of our loop, we're going to point this node to prev, which in the first case is going to be null. And next, you can kind of just disregard this for now. This is just going to be a temporary pointer. So all you want to do is just put your normal loop to loop through a linked list. So we're going to say while current is not equal to null, meaning we still are at a node in the list. We're going to say that next is equal to current.next. Current.next is equal to prev. Prev equals to current. And current is now equal to next. So I guess I'll just explain the reasoning behind this. So we're at the 1, right? And we want to point this to null. In other words, backwards. But before we do that, we actually want to save a copy of the next pointer in the list. So that's exactly what we're doing here. So we're saying that next is equal to current.next. So at this iteration, next would actually be equal to 2. And then after that, we're now saying that current.next, meaning current.next for this node, is now pointing to prev, which equals null. So that's the reason why you want to save the pointer before you do anything with the .next pointer. You want to actually save the next node in the list. And this is a really important step. Otherwise, if we didn't do this and we just automatically set the node that we're currently at to prev, then we wouldn't be able to get to the next node in the list after that because we just changed the pointer. So we take a copy of the next node, and then we set the current node.next pointer equal to the previous node. And then we say that the previous node is actually equal to the current pointer. And what this allows us to do is when we move to the next iteration of the loop, meaning, oh, we're at 2 now, prev is actually going to have 1 stored in it. So that's going to allow us to point the .next to prev, just like we did. And this can kind of look weird at first, but once you actually kind of work through the logic on your own, it makes a lot more sense. Oh, I'm sorry if I'm kind of confusing you a little bit, but if I were you, I would maybe write down on a piece of paper and kind of just work through it. And then obviously at the last stage of the loop, you just want to set the current equal to the next. And this is essentially just moving you along the nodes in the list. So this is nothing more. You've actually used this before plenty if you've iterated through linked list. So I would say just become familiar really with these 3 parts. And once you kind of get a good idea of what this is doing, then it should make a lot more sense. And so if you were to work through this whole linked list, you would eventually end on 5 here. And at 5, current would not be equal to null. You would then say next is equal to current.next, which in this case 5 doesn't have anything after it, so then it would actually become null. And by null I mean next. This next variable would become null. And then current.next will now point to prev, so you would say 5 now points to 4. And then you would say prev equals current, which would be 5. And then you would say current equals next, which would be null. And then when you actually would move to the next iteration, because current is now equal to next and this next has nothing after it, then current would actually be null and you would get out of the loop. And then you would actually realize that the previous variable is the one that stored the last node that you got to. And this would actually now be your beginning node in the reverse list. As you can see now, it's 5, 4, 3, 2, 1. So at the end of this, you just want to make sure that you return the previous node. This is another important part. And assuming we run this, I guess I can just submit it. I've already tested this before, but this is the iterative solution to reverse a linked list. So I apologize at any point if I confused you a little bit. If you have any questions, feel free to leave a comment. I'll definitely respond to it. And if this helped you in any way, a like would definitely be appreciated. But this is the algorithm. And like I said, if there's any questions, just leave a comment. And hope you enjoyed. Bye-bye.